Looks like we're live. Hello everyone and welcome to yet another recreational programming session. Let's make a little bit of an announcement on our Discord server and officially start the stream. So let's do the usual thing. Alright, the circle live on Twitch. And what are we doing today on Twitch on .television? I think we are rendering textures. I forgot to bring the panel that allows me to grab the titles, so it's kind of embarrassing, but it is what it is. Rendering textures, and I'm gonna give the link to the Twitch chat, twitch.tv/Sony, and I'm gonna ping everyone who's interested in being pinged. There you go, and the stream has been officially started. Hello everyone, welcome. So let me open the description. I think I already have it in here. So today we're gonna continue developing Olive.c or Olive.c, depending on how you want to pronounce that. It's a simple graphics library in C, which renders everything into memory. It doesn't depend on any third-party dependencies, except maybe Lib.c. But even Lib.c is kind of like an optional thing. You can quite easily get rid of that dependency. So you can find this thing in here. I'm going to copy paste it in the chat. And if you're watching on YouTube, it's going to be in the description. Maybe it depends on how I'm going to cut the video and stuff like that. Maybe. We'll see. So let's continue developing this thing. So I wanted to start today's session with developing something relatively simple to sort of like warm up, if you know what I mean. And I wanted to implement rendering the textures, or rather copy canvas onto canvas, right? So for some reason I actually denoted it as copying canvas onto canvas, but that's basically like texturing the thing. So essentially I want to be able to take one canvas and just copy it onto another canvas. But what's interesting is that I want this to be sort of like ratio agnostic, in the sense that, all right, so let me actually draw that. I wish my paint was already started, but it is what it is. All right, so I'm sorry, I just have a very small desk. Just like my PP. Anyway, so imagine that you have like this sort of texture, right? Sort of this texture, and you have this canvas, right? You have this canvas, and essentially I want to be able to copy this texture onto this canvas and actually make it fit into these proportions of the canvas. You know what I mean? So essentially it's sort of like its width is bigger than its height. So I want it to be like sort of stretched out like that. So through this mechanism, you would be able to resize textures and stuff like that. You know what I mean? I think it's a rather interesting idea. Furthermore, I want this mechanism to actually fill in the whole canvas, right? So you provide the texture as a canvas, and you provide the target as another canvas, and it actually fills in the destination canvas completely. You may probably ask, wouldn't it be better if you could like basically provide a rectangle within the canvas to fill in, right? Because that would make sense, because usually I have a texture and I want to like slap it onto the canvas somewhere in some sort of sub-region. Yeah, it's true, and that's why we have a mechanism of sub-canvases, right? Remember how we developed the mechanism of sub-canvases, right? So you can actually take the area of a canvas and make it a canvas on itself. So essentially, if you want to fill in a texture of a certain sub-canvas, you just take a sub-canvas of that region, right? So, and essentially the mechanism is going to be just copying the texture from one canvas to another canvas, filling in the whole canvas, right? And that way you can control how to resize, how to stretch things, and also where to copy it, because you have a mechanism of sub-canvases. Does that make sense? Hopefully that makes sense. So yeah, it's a pretty simple mechanism that at the same time is very powerful, right? Because it allows you to like resize, make smaller, make bigger, change the ratio and stuff like that, and also put it in different places because you have sub-canvassing, right? So hopefully that makes sense. So we have a sub from Azura Akumore. Thank you so much for 6 months of Twitch Prime subscription. 6-month Pog. Your content has helped inspire me to get better at coding. Thanks for the entertainment and community. Thank you for the subscription. Thank you, thank you, thank you. Even though I don't get any money, I still appreciate the subscriptions, right? So, well, I mean, your money don't go to waste. You get access to the Discord server. You also get emotes and stuff like that. So, you know. What's up, FortiGamer? Hello, hello. Alrighty. So, let's go ahead and implement this mechanism, shall we? So let me see. I'm going to go somewhere maybe here, right? So all of that, let's call it maybe copy, right? So we're gonna call it copy, and we're gonna accept 2 canvases. So here's the first canvas, which is going to be, let's say, maybe destination, right? So, and then Olivet's canvas, which is going to be SRC, right? Furthermore, I don't know which one is it going to be. So I first wanted to put destination first to make it sort of like look like a mem copy, right? Because if you take a look at mem copy, so it accepts destination first and the source as the second. And the reason why it does that, it sort of like complies with the Intel assembly instruction order, where you have like move instruction, and move instruction according to Intel dialect first accepts the destination register or memory and then SRC. So to mimic that, the standard Lib.c library uses this kind of like order of the argument. And I was thinking maybe I'm gonna do that, but at the same time, maybe you want to say, okay, here is sort of like the texture and you're copying it to the destination. So it's kind of like it's a very opinionated thing. I don't know which one is better. So I'm going to go with that order, right? So because it's not about really copying the memory, but you effectively copying the memory anyway. So I don't know. Marcior Veneto, thank you so much for tier 1 subscription. Your first subscription, by the way. Thank you, thank you, thank you. All right, so all right, how we're going to be copying all of that? So essentially, it sounds like a rather complicated, you know, task, because you need to fit one dimension into another one, right? So you have to also stretch and squeeze and stuff like that. So it might require a lot of code, but this is not true. This is actually not true. So R2 Laser, thank you so much for Twitch Prime subscription. Thank you, thank you, thank you. Really appreciate that. So essentially, we can actually iterate a normalized coordinates of the texture, right? So this one is rather interesting. So imagine that we have a destination, right? So so this is the destination canvas. So destination canvas, and we have some sort of SRC canvas. So what we're going to be doing, we're going to be iterating pixel by pixel. A camera died. Okay, so I don't know what the fuck has happened, but let me. Oh, I see what's going on. Is it better now? Can you see me, chat? Am I visible? I suppose my camera died for a second and OBS actually lost it. Okay. Okay, thank you. Thank you so much. I really appreciate that. Okay, so the idea is the following. We iterate destination, pixel by pixel. And my camera has died again. What the fuck? Excuse me. I don't know why it keep dying. Why are you keep dying? What the fuck? That was weird. I don't know what's going on. Anyway, you iterate destination pixel by pixel, right? So, and let's take a look at this specific pixel. It has a coordinates of x and y, right? So what you essentially do, you take the width of the destination and the height of the destination, and you divide x by width and you divide y by height. That way you actually get normalized coordinates from 0 to 1, right? So no matter how you go, all of your coordinates are going to be now from 0 to 1. And what you do now, you take these normalized coordinates, right, and you essentially multiply them by the width of the source, right, with SRC. And effectively you map the normalized coordinates to the SRC. And that's the color of your pixel that you have to copy in here. So you see, we essentially normalize the coordinates of both source and the destination, right? And we iterate the normalized coordinates, and that way we can map the space of the source into the space of the destination, and it automatically stretches, squeezes, and stuff like that. Right. And that's basically what we're going to implement, right? Alrighty, so let's go ahead and do that. I have to keep my eye on the camera because it can die at any moment, unfortunately. So, alright, so we're gonna iterate the destination. Can you hear the music? Yeah, okay, the music is there. So I'm gonna be iterating y, starting from 0, dest. You know what, I want to call it DST because source is called SRC, so it has to be DST. So this is height plus y, and then size tx, right, size tx, DST width. There we go. So we're going to have sort of like a normalized thing. So I'm not gonna put any type in here, right? So I just, I'm supposed to put float in here because from 0 to 1 it's gonna be float, but I'm not gonna put any type in here. So what I'm gonna take x and divide it by DST width, like so. And then y divided by DST height. Right, and after that, what I'm supposed to do is I'm supposed to multiply it by SRC, SRC width and SRC height. Right, and that way I should get the coordinates of the pixel. But I'm gonna do my usual thing where I'm gonna just do all of the computations in higher resolution, effectively performing the multiplication first and then the division. Right, so because once I perform the division, I'm gonna cut out the fractional part, and this is the fractional part that I don't care anyway. I would cut it off by flooring anyway if I use floating point. And that way I can just like use size t, right? And now I can be sure that if I take, for instance, Olive.c pixel for SRC, and x and y, it will be within the range, hopefully. I'm not 100% sure, but we'll see. So x and y, there we go. Interestingly enough, that is it, I think. I didn't expect that that's going to be the whole algorithm, and it doesn't even use any floating point. That's what's interesting about it. Yeah, that is basically it. And what's interesting is that it supports also sub-canvassing and stuff like that, because Olive.c pixel actually uses the stride. So that means you should be able, yeah, there we go. So it takes the stride. Great stream, see you next time. Thank you so much. Yeah, that's the stream. That's basically the stream. So thank you so much. But we need to test that, right? So we need to test that. I haven't even compiled that code yet. We don't even know if it compiles or not, okay? So let's actually try to maybe test that and compile and stuff like that. So I'm gonna download this image because that's gonna be the image that we're gonna use for testing. Right, so I'm gonna do... You see, I didn't even save the file. Right, so this is a temporary file that is usually created by Emacs when you didn't save the file yet. It is usually needed when you, for instance, crash Emacs, so you can recover your previous copy from that file or something like that. I don't quite remember, but it is a thing in Emacs. So I not only have not compiled that file yet, I haven't saved it yet. So I don't even know if it's savable, let alone compilable. You know what I mean? So... anyway, so I saved it, so at least it is savable. So let's test if it's compilable. Well, it's compilable. All right, so that's cool. Anyway, let's actually download the emote. Just a second. I'm gonna copy paste link yet again because I lost it, and maybe I should do something like Ep.10 POG PNG. There we go. So we've got Ep.10 POG. Isn't that Ep.10 POG? Can I actually make it a little bit bigger? Black. There we go. So this is a big ass Ep.10 POG. It's also pixelated. RTX on, RTX off, RTX on, RTX off. Anyway, so let's go ahead and test all of that. So what I'm going to be implementing, so I need to let's do the animation where I actually like sort of like squeeze the thing. I think you can see that animation in a clowning mode, right? So if you do something like clowning, clowning, right? So with the mechanism that I just implemented, I didn't want to open that, what the fuck? So it's quite easy to implement this kind of animation, right? Because essentially what you do, you just change the destination canvas sizes like according to this animation, and it automatically just stretches and squeezes the whole thing. So we can try to implement this stuff with the library just to test if this entire thing works. You know what I mean? Right, let's go ahead and do that. Sounds good, sounds Gucci, sounds Tamaguchi. Okay, anyway, I'm sorry. So squish.c. Alrighty. stdio. So the first thing I probably want to do, I want to load the image, right? So let me include third party, and it's going to be stb image. There you go. Droko87, hello, hello. Welcome, welcome, welcome. Define stb image implementation. Okay, so this is the implementation of our... I'm not going to say that. It's a dead meme, I'm sorry. All right, so how do I even use this thing? stbi read load. Oh, it's literally stbi load. There we go. Now, okay, so we have file name. Let me put it like this. File path is going to be sodium a pog png, right? File path xn. So n basically gives us the amount of components, and I don't really care about that. And this thing says how many components do you want to have, right? I think that's what it says. Right, so what I have to do, I have to say 4, right, and regardless of like how many components it has, the image actually has, it will just perform the conversion, so I don't have to worry about that. And I want to automatically actually convert this into pixels. There we go. So you in 32T, there you go. So, and if this thing failed, we have to say that we couldn't read it. fprintf std error, error, could not read file this because of this. So the file path is that, str error, error no, right, and I'm going to return 1, like so. Cool. Now, let me try to compile this entire thing. Squish.c. And also I'm going to try to run this entire thing. Okay, so we don't have semicolon in here. Let's put a semicolon. Error null. Let's put error null in here. Do we need to have anything else? Okay, that's cool. We also need to link with the math library, right? Because STB requires the math library to actually properly parse PNG. Okay, so it didn't complain about anything, right? So maybe I'm gonna even put something like OK to make sure that, you know, it read everything successfully, which is kind of cool. Alrighty. So, no, I don't know. Let's maybe allocate another canvas right now, right? So like completely another canvas width, and let's say it's gonna be 800 and 600, right? So my usual size, my favorite size. So this one is going to be called SRC, right? So these are SRC pixels, and here we're gonna have destination pixels, right? So this is gonna be DST width by height. There you go. And what we want to do in here is essentially just do the copy. Rock87, thank you so much for 13 months of Twitch Prime subscription. Sodium Pog indeed. Thank you, I really appreciate it. All right, so let me go in here. Olive.c copy. There you go. So src is basically Olive.c canvas, right? We provide src pixels x and y. For the destination, right? So where exactly we're copying everything, we're gonna do Olive.c canvas dst width and height. There we go. So canvas is actually very lightweight view on the array of pixels. So that's why it's super easy to just create two canvases, copy one thing into another one and just like forget about them. Because the actual data, actual pixel data of the canvas is stored within like within this area and within the area allocated by stbi load, right? So we just create a temporary view on these pixel areas with a certain stride, width and height and stuff like that, and then we just forget about them after we fill them in, right? So that's kind of the idea of this entire stuff. All right, so now after all of that, we can just go ahead and try to save the destination canvas, right? So to do that, I need another third-party dependency. So what's the point of this library if I have to include like two third-party dependencies? I'm not even sure if I'm including the original library, right? So yeah, as you can see, it doesn't even compile because I don't include the original library. So let me quickly do that. Olive.c implementation, right? So I'm going to include Olive.c. Right, so let's just try to compile this entire thing, and it compiles and doesn't even crash, right? It actually performs the operation that we implemented, right? And at least it didn't crash. At least it didn't crash, which is already kind of good. Maybe we can do something like val grind just to see if it doesn't try to poke and touch the memory that it's not supposed to poke and touch, if you know what I mean. It's probably going to complain about leaked memory and stuff like that. So how much did it leak? Yeah, so we leaked some memory because we didn't free the allocated memory by stbi load, but apart from that, it doesn't complain about incorrect reads or writes. So that means we didn't do any out of bounds stuff. Better than Rust. I wouldn't say that it's better than Rust. But by which criteria though? Right, so what's the criteria? How do we, by which dimension? I mean, in terms of safety? I wonder if something like Clang memory sanitize can actually replace like Rust runtime checks. Memory sanitize or sanitize memory, right? Something like this. Right, and if I go to Olive.c, right, and then just accidentally, just slightly accidentally put equals in here, it should crash. And as you can see, so we instantly crash and tell me that you're trying to do incorrect write. Right, and it even tells you like a stack trace and stuff like that. And this is C, by the way. Who needs Rust when you have Clang and sanitize memory? Am I right? Nobody needs that. So it's safe. Just a single flag and you have a safe C. I'm joking, by the way. Rust memory safety model is a little bit more complex than that, but you get the point. Anyways, so now let's go back to Squish, and maybe one of the things I have to do, maybe I have to free the memory, but whatever, I'm gonna spend my time on that. All right, let's include the stb write thingy. So define stb image write implementation, and I'm gonna just include this entire thing. So it's a third-party stb write. Third-party write stbi write png, right? So we're gonna save everything in png. Okay, so this is a file path. Let's call this maybe src, right? So this is gonna be file path src, and let's introduce something like file path dst, right? Sodium pog stretched png. There you go. So this is a file path dst. Width and height. Width and height is gonna be like this. The amount of components we have is 4, and we use the destination pixels. The stride is the size of the row in bytes, which is essentially width multiplied by size of of the pixel, and the size of the pixel is the size of U in32. So if it fails, it usually returns 0, right, indicating sort of like false, and we need to catch that. std error could not write file s because of s. There we go. So file path destination str error null, and I'm gonna do return 1. There you go. So let me try to run this entire thing. Oh boy. So, and we got sorting pog stretched. So as you can see, it is in fact stretched. So if we open a different one, right, like this one is not stretched. So we basically managed to change the dimensions and fill this entire thing in using only, you know, normalized coordinates, right? So we iterate the destination by normalized coordinates, we map those coordinates back to the SRC, and it just does all of that magic automatically, which is kind of cool. Natsu130, thank you so much for 2 months of tier 1 subscription. Thank you, thank you, thank you. Really appreciate that. So yeah, this is a very simple algorithm, and it does a lot of things. Stretches, squishes, can do rotation, I think. I think you can even use it to rotate things around, right? So if you have a rotated triangle, right? So the only thing you need to do for a certain point on that triangle is to normalize it, then look up the pixel for that normalized coordinate, and then just put it in there. It's kind of similar how OpenGL works, actually. Right, so in GLSL, there's a texture function, right? I think I'm literally reinventing OpenGL, right? So you have a sampler, you provide a sampler, which is a texture, and you have to provide the point P, which is the UV coordinates, which are from 0 to 1. Yeah. So essentially what I'm doing here, I'm using UV coordinates to actually do all of that. That's actually cool, right? So it's pretty cool to reinvent these concepts, right? And not like intentionally reinvent, you just like trying to do something and you like unintentionally come up with the same sort of ideas as the industry standard, and you start to understand that industry standard a little bit more. I'm really sorry, my speech is actually crumbling. So that's pretty cool, I think. I'm drinking vodka today, so that's why it's clearer. All right, so let's try to animate that maybe. And speaking of, so the way you sort of place this thing onto the canvas, onto a sub canvas, you just do sub canvassing, right? Let's actually test that. I really want to like kind of test that. So I think I should actually call it Sordin, because in the original name it's just without G. And now let's create a canvas that is not width and height, but rather the original size of the SRC, right? The original size of the SRC. Though we have to make sure that X is less than width and height is less than height, right? So we can do that. Average Ruski, yeah, very funny. But the thing is, I actually don't drink alcohol at all. I haven't drinking any alcohol for like more than 5 years already, and to be fair, I do not regret that at all. So yes. So now we can do that, but we won't be able to really see anything. I think it makes sense to maybe fill in the whole canvas with something, right? I can do something like Olive.c fill, right? And just put width, height, and let's put maybe red color, right? So let's actually put the red color. There you go. Here's an interesting thing. Like, you see, when I'm filling in the whole canvas. But then when I copy it, I actually copy into the small sub canvas. Right, so this is actually pretty cool. This is basically where this canvas mechanism shines, right? So you use the same storage for the pixels, right? DST, the same storage of the pixels, but you use different dimensions, different sizes. Right, so that's actually pretty cool. Membrilla Marilla, thank you so much for 17 months of Twitch Prime subscription. Thank you, and welcome to our epic sub canvas club. How about that? But you didn't expect that shit to happen. Cheers, by the way. This one's for you. All right. So, but we're not even taking like proper sub canvas. We're just constructing original canvas, but with this one is actually kind of. This one is dangerous. This one is actually dangerous because we're constructing the sort of initial canvas. We're constructing an initial canvas. And when you're constructing the initial canvas, it actually sets the stride to the width. And this is not correct. Yeah. So it sets the stride to the width, you see in here, it just does that. And that is not bueno. This is not bueno whatsoever. So, because if you just provide the smaller size, you're basically gonna corrupt the whole memory. So what I'm thinking, maybe this thing should accept the stride as well. I think that will make sense, but that will require to actually, excuse me, go through all of the places where we do all of that and just like update this entire stuff. It would be kind of cool if the like C supported this kind of stuff, right? You could just say, okay, the default stride is the same as the width, and if you just don't provide that, it's gonna be that. I don't know. So by the way, I just realized that I didn't put anything behind my camera, so let me quickly do that. Let me quickly do that. Alright, so let's give it a try. Let's try to like provide this stride explicitly. So now we customize each individual field in here. And yeah, I think that's quite important. Okay, so let's actually go and recompile everything. So this is the stride. So I didn't update that in the declaration, right? So I have to put stride in here. So what about that? Okay. So, and now in the test, when we're constructing the canvas, we have to also provide the width as the original stride. Okay. So, what does stride mean in the context of the images? Okay, so let me show you. That's a good question. All right. So imagine that you have an image, like not really an image, but the area of the memory that can fit this sort of image, right? So usually you can split image by rows, right? So these are the rows, and usually you store such image in the memory row-wise, meaning that each row is sort of like stretched out. So after the first row, in the memory, in linear memory, usually comes the second row. But for the sake of simplicity, I'm going to be displaying this rows like vertically, right? Because it makes sense. So quite often, the image doesn't take the whole width. It doesn't take the whole width. For instance, the width of the image, the actual width of the image can be this, right? And this padding should be ignored usually. And the actual width that you have to skip to get to the next row, right? To get to the next row after the first one, right? Is called stride. That's what it is. So stride is the actual width, like the whole width. Maybe the old version of the FN could be like Olive.c canvas feed that can assume stride is width. I don't know, it's all about backward compatibility. We don't have this library developed yet to actually care about backward compatibility. And why the hell would you even need that? So some of the like old graphics card, I think graphics API require you to pad things appropriately and stuff like that. But furthermore, this stride, the concept of the stride has practical use, regardless of the hardware or any limitations imposed by APIs and stuff like that. The practical use for the stride is being able to take a sub-canvas or sub-image of the image. Right, so imagine now that you have this image and you want to actually take a sub-image of that image and do all of the drawing operations inside of this thing. Right, but you want these two images to actually share the same memory, meaning that if you make any modifications like in this area, it's going to be visible to the bigger image as well. Right, it's a sub-image, just like substring, but it's two-dimensional. It's a two-dimensional substring. So the width of this thing is going to be one thing, but to get to the next row of this image, you would have to skip width plus additional thing, and that additional thing is the width of the bigger image, and the width of the bigger image is the stride for the smaller image. You see what I mean? Right. This is precisely how we use that in a library, right? So if I take a look at Olive.c, Olive.c sub canvas, right? So there's literally sub canvas function, and when you do that, you provide the rectangle and stuff like that. What we do, we set width and height, but we leave the stride as the original stride of the canvas, right? So when you do sub canvassing, you change width and height, but you do not change the stride, because stride preserves information on how to get to the next row. Right, and to get to the next row, you need to skip the width of the bigger image. Right, so that's how we use that. Hopefully that makes sense. Hopefully that makes sense. Okay, so that's kind of the point. And that's why when we are creating the original canvas, I think we have to explicitly set the stride, because you never know what kind of stride you want to have actually there. Right, maybe you want to do like a sub-canvassing, but with this function. Right, who knows? Yeah. All right, let's continue. So we have to provide this in here. So, and because of that, I have to set the stride the same as the width. Okay, good. Statically typed compiled language, by the way. Can your JavaScript do that? Can your JavaScript actually point out to all of the places where you have to modify the function after you edit an argument to that function? I don't think so. To achieve even the fraction of this power, just the fraction of the power, you have to ask a multi-billion corporation to develop you a preprocessor for the JavaScript. Just to be able to do that. I'm talking about TypeScript, by the way. It's a fraction of this power, and this is a language from 1970. 1970, half of a century ago, people knew what's up. Half of a century ago. Using resources of multi-billion corporation to mimic a fraction of half of a century old technology. Pathetic. Pathetic. Fry, thank you so much for Twitch subscription. Thank you, thank you, thank you. Got him. All right, so let's continue. Alrighty. Okay, that's cool. So we already fixed everything. I also want to run the tests just to make sure that everything is okay. All right, everything seems to be okay. So, and when I try to do the squish, right, so the squish will also require to provide the stride. Right, so let's provide the stride in here. And in here, the stride is actually X as well, right, so that should be fine. It's taking some time. Clang is rather slow compiler, but it worked. So now if I take a look at the stretched version, right, so as you can see, we have the whole canvas, and we basically copy this thing into the sub canvas, and it actually works. So I use like a very bright color just to see that this is the background, right? So I can color it with anything else, but I wanted the color to be bright to make it more obvious. Right, so now I can also try to do the following thing. I can multiply this thing by 2, right? What if I take a bigger area, right? So that will automatically you know, stretch or scale the image, right? So let's actually take a look, and it actually scaled. Look at that. So that's actually pretty cool. That is in fact pretty freaking cool. So let's try to do animation, right? So let's try to do animation. So we already have a lot of like animation things in here. So I have been in here for some reason, I don't know why. And they use the same code. Right, so for instance, this is what we draw with our library, right? And to achieve that, we utilize SDL, and we just like render everything into the SDL texture, then we display that texture and stuff like that. And that code is basically the same for all of the interactive sort of examples, right? So we have a triangle example as well. Right, so, and every time I change something with that code, I have to actually change it in all of these examples. So what I'm thinking is that maybe I need to extract the code for interactive examples to separate file somehow, right? So I can just plug in that file and just do something with that. So, but I'm not sure how to call that thing. So that thing basically consists of, I don't know, just like a single macro that denotes for which platform you want to compile the interactive example, because you can compile it to different platforms. For instance, you can compile it to Wasm. You can make it work in browser, right? So let me actually show you. So if I do something like this, so this is a triangle, and I can load up 3D. And then I can do Python 3 HTTP server 69 as 69, and then I'm gonna open localhost 69.6, and there we go. It works in browser. So it doesn't even need SDL, right? So because again, it renders everything into the memory, and memory is the most cross-platform API, right? So you can just like dump something in the memory, and you can have a different program to interpret that memory somehow. So it works in the browser as well. Furthermore, it also works in a terminal, right? So let me show you Olive.c, and I can do something like a bin 3D terminal. There we go. So I actually need to do something like this. So it works in the terminal as well. Right, because it doesn't care. It renders everything in the memory, and then what we do, we just take that memory and we display it somehow. We just adapt it to a certain thing. I'm not sure how well it works. Maybe it actually has like a lot of like you know, artifacts and stuff like that. I really apologize for the artifacts. So the Jesus himself subscribed with Twitch Prime. Thank you so much, Jesus. I really appreciate that. All right, so okay, let me see. And as I already said, the code that is responsible for rendering to different platforms like Wasm, SDL, and the term, it's basically repeating among all of the things. So I need to extract it somewhere. I need to extract it into a separate file, and the question is, how should I call that file? So it's some sort of like a virtual console, right? Some sort of a virtual console, and I need to come up with a name for that virtual console that I can just reuse for examples like 3D or for the triangle and stuff like that. So I'm not really sure how to call that. So if it's a virtual console, right? But console in a sense like a, you know, video game console. Maybe I should call it VC. So something like VC. Doesn't look that bad, right? So maybe it should be called VC. So let's call it VC.c. Maybe I should have actually called it v.c, but it makes it sound like I'm doing like a V language or something. And now I can just copy paste this entire thing in here, right? And that is basically it, I think, right? So that's the whole thing. So depending on the platform, right? So you have platform SDL in here, and then you have platform term, and it just contains a different main point. And for the WASM, you don't have anything because you just like compile the library and expose the functions, and that's it. So this is the reusable code that I usually use for all of the examples. And okay, so an examples usually don't have like too many things, right? So they usually have like a single render function that accepts delta time for the animation, and that's it. And at the end in here, I probably want to just do vc.c, right? So, and then in the triangle, I want to do a similar thing. I'm gonna just include vc.c. So, honest question, do you work as a professor? No, I never worked as a professor or in university or in educational systems, to be fair. And to be fair, like, I kind of want to work as a teacher, but I don't want to be part of this horrible system that traumatizes people for the rest of their lives. I don't want to be part of that. So, yeah, I want to teach people, but I don't want to teach people through the education system, through the modern education system, because it sucks and it's actually dangerous for humanity, in my opinion. Because it literally traumatizes people. It makes people hate things like math and science, the very things that actually changed our lifestyle and made it better, right? So the entire system actually like rises a generation that is not going to be capable of reproducing this style of life when it crumbles and fails at some point, because they are afraid of the things that we teach them. So, yeah, I don't want to be part of that. I want to be part of the collapse of the civilization, I'm sorry. Anyways. Okay, so we have this file and stuff like that. And now, I probably should be able to just include that squish file in here and it should be fine. Okay, so let me recompile the whole thing. Just to make sure that everything compiles. And there you go. So, Walrus Operator, thank you so much for Prime. Nice one. Nice nickname. I suppose you are a Python compiler, a programmer. Maybe you're also Python compiler, I don't know. I ran out of water, by the way. Anyway, so so here's the thing. For the squish, what I need to do, right? Day job is Python code. Okay, so Python becoming like a lingua franca of computing in general, right? So I guess that's totally fine. Right? I didn't see anything wrong with that. It's not particularly the direction that I would personally go to, right? But it is what it is. So Python became #1 language, right, according to TOB index. Let's actually take a look, right? So, and to be fair, in all fairness, that's not the worst language that has been on this place. We had different languages in this place, and so far, this is not the worst language, to be fair, right? So it's not the worst one, so I'm totally fine with that. Anyway, we've definitely had worse, that's for sure. Right, so for the console, speaking of the console, we need a way to do a little bit of an initialization before we can actually run anything, right? So that's one of the things we need to do. And I'm thinking, what's going to be the best way? So we can introduce, for the console, we can introduce the init method that should just have to call. And in that init method, we're going to load the file. But the problem is here, the problem with this file is, we also need to run that in WebAssembly, right? We also need to run it in WebAssembly, and WebAssembly, this thing is simply not going to work, I think, unless we'll try to maybe implement like open file in JavaScript. Yeah, so what we do on this channel, we implement Lib.c in JavaScript. We can try to do that, but I'm not really in the mood of doing it right now. So what I'm thinking is that maybe I'm just not gonna compile Squish example for WebAssembly for now. Fast Magic 47, thank you so much for 2 months of tier 1 subscription. Thank you, thank you, thank you. Really appreciate that. Really appreciate that. Thank you. Alrighty, so okay, I'm gonna go to here and just do the following thing. So in here, in main, we call render, right? We simply call render. Where's the render, right? But before doing anything else, I think it would make sense to maybe just do init, like so, and in here, init as well. So we're gonna introduce like additional function that we'll have to call, and it will probably also make sense to call that function in the JavaScript as well, right? Before doing anything else. So here we call render. Where is the render? I can't see render. Oh, here it is. So, and before doing anything in here, we can just do instance export init. There you go. Right, cool. Cool. So I suddenly programming in JavaScript. You thought it's a C stream, but here's the JavaScript. All of a sudden. Welcome to the modern world, where we have web and low level actually interleaved with each other, right? Because everybody wants to do everything in the browser, but at the same time browser sucks. So what people do these days, they just make a lot of bindings for C libraries for web. And I'm not even joking, by the way. So a lot of like new technologies in web are literally bindings for the C libraries. Things like WebGL. It's literally binding for a C library. Right. Anyway. Okay, so we have to have init here. So that also means that we'll need to provide such functions in here as well. Right, we're not gonna do anything in them, right? But we're gonna just have them just in case. Render. Right, init void, and let me try to compile that one more time. One more time. Okay. So what I plan to do is maybe move that squish example to here, to examples. Right? So this is a squish example. And when I do the build, so okay, in here we have a compilation of a single interactive example, right? So this is a single interactive example. And we compile it for WebAssembly, for SDL, and for the terminal. And then for WebAssembly, SDL, and the terminal. So maybe it makes sense to probably factor this out into a separate bash function, if you know what I mean, right? So maybe we could do something like function build VC example, right? So the example for the virtual console. I don't know how to, I don't remember how to make custom function in bash, but I think this is how we do that, right? So I'm pretty sure that's how we do that. All right, so in here we can just do that, and essentially we're going to have a name provided as an argument, right? So the name for this thing is a triangle, right? So triangle. And I suppose this is how we can do that. We're going to replace the triangle with the name, right? And there we go. And if you want to build a triangle, you just do build VC example triangle, right? And it will just apply this sequence of commands for the triangle and beat the triangle. So another thing that we have in here is the 3D example, right? So we can do build VC example 3D. So that should work. So here we just build tests and gallery and stuff like that, but here we have a special command that builds example, because examples usually include building for different platforms like SDL terminal, WASM and stuff like that. So basically, the try principle, the principle that everyone is screaming at me in the comment section on the YouTube, right? People get really annoyed when I repeat things, right? So there you go. Here's your dry principle. Are you happy now? Are you freaking happy? Anyway, so it doesn't even work, right? I suppose this is because in shell, in the original shell, maybe you just don't have parentheses. I don't quite remember. Okay, so here's another one. I think it's like this. You just say, okay, that's the function. Yeah, there you go. There you go. So that's how we define the functions in the POSIX shell, right? Absolutism in software development is it is actually. I do agree with you. I could not agree more with you. It's usually practiced by people who don't really program that well, right? So, and they sort of like compensate their inability to program with shed ton of dogmas, right? So they can't develop software, so they just being very dogmatic about it, thinking that that's how we develop software, when in reality it is actually not. Yeah, a lot of rules or best practices, they're actually rules of thumb, right? So they're not, people did not come up with them to strictly follow them. It's just like, yeah, that's how roughly you have to do, but it depends on the situation, right? It depends on the situation. Okay, so as you can see, it works. So we dried this thing a little bit, right? We dried this thing a little bit, and now if I need to add another example, for example, squish, right? So I actually copy-paste squish in here. I can just do build VC example squish, and it will automatically build it for 3 different platforms: WASM, SDL, and for the terminal, right? So you don't have to worry about that. So that's how we abstract things away. Interestingly enough, well, this thing doesn't really compile properly, but yeah. So, and it's super easy for me to, for instance, for a while to disable those things, right? So for instance, I want to build those examples. In fact, I don't want to build anything except this squish example, right? So to speed things up, and assert file not found. Why the fuck would it not be found? Oh, this is because of the, okay, I see. Well, I mean, I probably don't really need that in here. Okay, so this is the main, well, there's a lot of things here that don't really make sense, right? So first of all, I have to have a renderer, right? A render function which accepts DT and returns some stuff and blah, blah, blah. We have to return DST in here, that's fine. So, and we also need to have initialization function, which is called only-once. And in that initialization function, we're going to be loading the PNG file, right? So we're basically loading PNG file. But at the same time, I also need to store the source. So what I'm thinking, I'm gonna take X and Y, put it in global, and do int32 src. Like having global variables is another thing that people scream at me all the time, right? So they're saying that I'm stupid for doing all of that, but in fact, I'm very, very smart. In fact, very, very smart, because what I'm organizing the communication channel between 2 pieces of code, right? So I have this piece of code, and this piece of code needs to communicate to this piece of code, without calling it directly, the image that it loaded up from the file. How would you do that? People come up with all sort of pseudo-intellectual solutions, like maybe some pipes, some channels or stuff like that. No, just create a global variable. Just create a global variable and pass that information to the global variable. But my thread safety, some people will ask, well, you have a single thread. Isn't that amazing how majority of the thread safety concern go away as soon as you start doing single-threaded and actually justifying single-threading? Right, isn't that cool? When your problem can be solved in a single thread, and because of that, you don't have to worry about thread safety. Isn't that amazing? That's freaking amazing. I ran out of water, by the way. Anyway, so what we're gonna do in here is just that. Cool. So this thing should compile now. And of course we have to include the vc.c. Okay, so stdio, we're probably gonna have to do that as well. Oh yeah, so that's the problem, by the way. I just realized what's the problem. As I already said, it's not gonna work in WebAssembly, right? So it's not gonna work in WebAssembly at all. So because of that, we wanna just do that. And in here, maybe we want to actually do exit1 to indicate the error, right? So that's the error. And this is a DST pointer. Yeah, this thing is supposed to return uint32, and this is the point. There we go. Okay, is it compilable? Looks like it's compilable, hopefully. Why does it take so much time? What? Ah, I think I know. It was so weird why it was taking so much time. I think I know why. Because of these things. So I put, if you try to compile STB libraries with Clang and O2, it will take unreasonable amount of time, just like a ridiculous amount of time. Because these libraries are quite big and a lot of things there are quite inlineable and stuff like that, and it's just like Clang starts to choke on this library. I know about that, I encountered that before. So essentially STB, if you want compiling STB libraries faster, you just don't do that with O2. Right? Or maybe like I don't need to do write at least, right? So I need to only read. In fact, why can't I read this image at compile time and bake it into the executable? Why can't I do that? Just like in Jai, I mean, right? Because if I could basically bake it into the executable, it would automatically work in WebAssembly as well. So I won't have to worry about like different platforms and stuff like that. But this is C. We're developing a library for C. Maybe I should port this library to Jai. That sounds like an interesting idea. What if it was like a purely Jai library? No? Because why not? So if Jai is gonna be the next C, maybe. Maybe we'll see. Zedin, do you make code reviews? No, I don't tell people what to do with their code. If you have a very specific problem, you can tell me that problem, we can discuss that, but something like look at my code and tell me what's wrong with it, I won't able to do that. I just won't able to do that. It's your code. You are the owner of your code. You do whatever the fuck you want with your code. Who am I to tell you what to do with it? Right? So maybe you're copy pasting the code all over the place. Maybe you're using shit ton of global variables and maybe that's what you need to do. Who am I to tell you not to do that? Maybe that's what you need. I don't know, it requires studying your requirements, it requires studying your project, your goals and stuff like that. It's depends. I'm just hyper aware of all of my design decisions. Okay. I don't think it matters. Just solve the problem in the most dumb and simple and quick way possible, and if it works, that's the best way to do that. Seriously. So people always like don't know how to come up with the proper solution, Just do the dumbest shit possible as quickly as possible. And if you never have to change it, that's how you do that. Because you end up not wasting too much time, and you have a solution that you just use all the time and it never changes. So that means you basically solve it in the most optimal way in terms of resources. So don't even worry about it. Just like, you know, slap some code and just like do something with the duct tape, and if it works, it's fine. If it starts to cause problems, only then it tells you that you need to put a little bit more effort into that, and that's already completely different story. So as you can see in here, I just pass things through the global variable, and it's fine, it works. It works. This is not like a program for the nuclear plant or anything like that, right? It's just like a dumb little program that I'm running on my 10 years old laptop, so don't worry about it. Just my advice. So I think I kind of know why people are super aware of their technical decisions, and they always want to follow the best practices and stuff like that, and they always ask for the advice and review. It's because they are afraid to fail. People are extremely afraid to fail, and they try to prevent failure, whatever we consider failure, by following the best practices. And maybe if they fail, that's not their fault, right? Because they follow the best practices, it's fault of something else. So they're always trying to get away from the fault. But failing is a part of the design process. It is a part of the design process. You never fail. You gather information. You gather information. Right. So for instance, you use global variable, and that caused all sorts of problems with multi-threading. And so now you know that you need multi-threading, right? You didn't know that before you started to develop this entire thing. It's a part of the design process. You never fail, you gather information. So my advice is to don't be afraid of failing. Right? It's a part of the process. You're gathering information. Anyway. So we have in here, we have a used variable. Oh yeah. I completely forgot what I was about to do. I wanted to, you know, reduce the optimization. Okay. So let's make it, maybe let's remove the optimization altogether, right? Because it doesn't really, it's not particularly useful. Malaris fails in my programming career appeared when I followed different sorts of design guides. And this is fine. You gathered information. Now you know that they're shit. How would you know that they're shit if you didn't follow them and failed? You didn't fail. You gathered information. Nobody will tell you that. All of the proponents of these guidelines and like methodologies, they will always try to sell you that. They will always tell you that they're good, they work. Of course. So nobody's gonna tell you that they're bad and don't work. You can only gather that information yourself. It is part of the process. You see, it's very important. It's very important to try them and see that they're shit. Right? It's very important information because nobody's gonna tell you that. All right. The Stallman GNU-C manual didn't include the smartest advice. I guess. Is there like a Stallman GNU-C manual? I never actually heard about it, but yeah. Anyway. DT, alright, so this seems to be working. This seems to be working. I'm not sure if I care about this thing, but that should be fine. It's quite recent. Interesting. Stallman GNU-C manual. The GNU-C reference, is that this one? I'm not sure. No, it's created by a young man. Young man. Young man. DMCA. Okay. I don't know. I never read a single book about C. I'm never gonna start anyway. All right. So let's try to run Squish, and we even have that for different platforms. Look at that, and there you go. That's cool. So I factored out the like a virtual console, and now I can just like use it. That's actually very cool. And theoretically, the virtual console works on SDL and the terminal, so that means I should be able to do things like squish turn. Well, okay, so I have an idea. We can make it a little bit more interesting. Let's do reset. Yo, this virtual console could be its own library. Like a separate, because like this virtual console is so goddamn useful, but it's completely outside of the scope of what I'm developing. So I feel like I want to make this a separate library. Right. I'm not sure, should I make it part of the Olive.c? Because I can hide it behind the macros, so when you include it by default, it's not going to be affecting anything. And I can make it so you can include a certain platform by just enabling it or something. I don't know. We'll see. I'll have to think about it. But yeah. Oh, okay. So let's take a look. C intro and ref. Okay, so that means I have to do git clone, right? Is that what I'm supposed to do? There we go. Savannah. Tree. Okay. Let's do a clone. Let's do a clone. Let me see. New buffer. Okay. GNU still doesn't get the concept of HTML websites. I mean, I kind of agree with them. And it's just DTGZ. Wait, do they have a make file that just like tar zips this entire thing? Why? Oh, okay, so you can actually create different things. Okay, you have to do cpdf, right? So if you want to have PDF, you just do that. Okay. And luckily I do have LaTeX installed on my machine, so that should be fine. So just builds the DVI, and where is the PDF? And new PDF, let's actually open that. Let's see. Okay. GNU C language introduction. Maybe I can do something like this. Okay. So do we have a young man? There's no young man, unfortunately. There's only old man or Stallman. The first example, a complete program, storage, data, arithmetic, assignment. Oh, it's just like a cookbook. That's pretty cool. All right, so let's take a look. Oh, that sounds interesting. Thank you so much. All right. Recursive Fibonacci. So this is the first example. In this chapter, I present the source code for a very simple C program that uses explain few concepts, blah, blah, blah. So this is that function body, the stack and stack overflow. Ooh, okay, this is like a textbook for C. That's an interesting one. Thank you so much. I'll probably read that off screen. I'm gonna put that in the description as well for anyone who's interested. All right, so let me see. So what I want you to do, right? I want you to actually not really squish this entire thing, but stretch it like along everything, right? So I'm stretching it along everything, and now I'm gonna rebuild this squish thingy, imaging it, and now I'm gonna just run bin squish. I want you to do SDL. It's kind of hard. Squish SDL. There we go. So that's what we have. So, but I also want to make it smaller when I render it in a terminal, right? So let me go to examples VC and scale down. Okay, so we have a scale down factor. This is the value by which we divide the size of the screen, right? So when I have a feeling that this thing has to be defined in the example itself, right? So we have to define it in the example itself. So it's going to be example squish. So because we define width and height, it probably makes sense to define this thing here as well. So let's actually say it's going to be 30. I think 30 is not divisible by those things, so I'm going to do it like this. All right. So I'm going to build sh and boom, 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 boom. So what's that? Squish term. Does it look like Tsoding Pogue? It kind of does, I think, a little bit. So yeah. I like Poet. I don't know how to pronounce your nickname, but thank you so much for Twitch Prime. Thank you, thank you, thank you. Yeah, so it's a Tsoding Pogue. Tsoding Pogue. We can make it a little bit bigger to actually not lose too many details. Right. Yeah, it's a little bit bigger, so now you can see that it doesn't lose that many details. That's actually pretty cool. I like that. Anyway. So the point of this entire stuff, right, is to animate that, right? So as I already said, I want to do an animation similar to clowning, right? So clowning, right? So I want to do animation similar to this one, and to do that, we need to animate the sine wave. Right, so we need to animate the sine wave. The easiest way to animate sine wave along the time is to keep track of the time, right? So let's introduce time in seconds, right? And essentially every time render is called, we add the time, we add dt to the time. Now, when we do sine f of the time, we have a value from -1 to 1, oscillating as a sine wave, right? That's what we have. So I want to actually interpolate this thing and oscillate from 0 to 1, right? Because I think it will be easier to work with. Not necessarily, actually, maybe -1 is going to be fine. Because the way I usually do this kind of animation, right? The way I do this kind of animation is essentially I take the square, right? So I have this kind of square. And I put a virtual handle on the top side, right? So now I have this virtual handle. So, and I have the animated value, animated interpolator, right? And when it goes negative, when that thing goes negative to -1, I move that handle down, and as it moves down, it actually squishes the entire thing. So the smaller this height is, the wider the image will be. Right, when it's negative. When the interpolator goes up, I move the handle up, right? And as it moves up, it basically moves the width down, but it actually stretches this entire thing up. So, and by oscillating that single handle, I can actually like squish and stretch, squish and stretch, squish and stretch. And this is how I achieve this sort of effect. You know what I mean? So I want to do a similar thing in here. I want to do a similar thing. So let's go ahead and do that. And because of that, I think I'm going to keep this thing from -1 to 1, because it will just make it a little bit easier for me. So let's put this into T, some sort of a T. All right, so I think I need to come up with the width and height of the final image, so to speak, right? But we may not know what is it going to be. So, you know, I want to call this srcx and srcw, maybe even W and H, right? So I think it's going to be a little bit easier to work with. And what I need to have is scaling factor, right? So because I don't want to use the original size image, I want to scale it a little bit, right? So we want to be able to scale it. Okay, so maybe it's going to be something like define src scale, and we're going to scale it by, let's say 3, right? So this is going to be 3. So this one is rather interesting. This one is rather interesting. I just realized that there is a little bit of a problem with copy. But I guess it's fine. We'll see. We'll see. Okay, I'm not gonna fill anything with red, so let's actually fill everything with like a grayish color, right? So this is gonna be what we have. Maybe the first thing I want to do, I want to place the scaled up thing somewhere. All right, so I copy src to DST, but I'm going to be copying it at a different place. So here's the, let's actually have DST canvas, right? Olive.c canvas, DST canvas, right? So Olive.c, just something like this. So this is going to be the stride. Then I want to take the sub canvas, Olive.c sub canvas. I provide the DST canvas, and how I'm going to be sub canvassing it. Right, in terms of X, I want to start with half of the whole width, but minus half of the SRC width multiplied by the SRC scale. Right, and I actually want to take like half of that. Right, so this is X. Then, in terms of Y, I want it to be actually the whole height of this thing multiplied by SRC scale, but the whole height. And width and height is going to be SRC width multiplied by SRC scale, and SRC height multiplied by SRC scale. There we go. So this is the sub canvas, right? This is the sub canvas. Into which I'm going to be rendering everything, right? So we're copying this thing into this thing. There we go. So let's try to build this entire stuff. So it doesn't work because we have to actually do these things. That's totally fine. So this is SRCW and SRCH, SRCW, there you go. So we don't use interpolator, but that's fine. So there is some sort of a problem. Okay, so time is already taken, so let's call it global time. Time plus equal global time. Sure, that's totally fine. And this is a global time. Okay, I want to do bin squish. I want you to do SDL, please. No. One more time. Okay, so that's basically how it works. Interestingly, it didn't work the way I expected it, so it's still squashed. So it positioned it at the bottom, at the floor. That's what I wanted, so that's perfect. But it's still kind of weird, because I expect this thing to be, yeah, SRC width, SRC height, width and height. So it's supposed to be square, actually, right? If I put 1, why is it not square? So there's a bug somewhere. I don't really know where, but it is square. I see. Oh, I see, I'm an idiot. So it has to be height minus that thing, and that way it will actually place it on the floor. I see. Oh, yeah. I see what's going on. Cool. And let's actually scale it up. Maybe by 2. Let's scale it up by 2. So that's fine. Okay, let's try to apply the multiplier, right? So, and essentially, What that means, maybe I need to have a separate width and height of the final thing, right? So this is going to be width, and I'm going to put it in here, right? So our width is going to be that, our height is going to be that, and we can easily replace all of this stuff. So this is width, this is height, this is width, this is height. Cool. But now, so if t is smaller, right? So if t goes negative, we want to add more to the width. So that means we do minus t, and we want to multiply it by a certain size, but I'm not really sure. Let's actually say it's going to be like 100, but it should be dependent on something, I think. Right, so should be dependent on something. So we do -1, and in terms of height, we actually, if it's negative, we actually add to the height, which will automatically like sort of decrease it. So, and we also have like a some sort of a factor, right, that controls all of that, right. I think that's basically it. Yeah, boy. Would you look at that? That's the dumbest shit I've created. Okay, I can make it a little bit faster, I think. This probably can multiply it like by half. Right, so let's go ahead and do that. That's so cool. Like that. Did it actually work? I don't think it worked. So what if I multiply it by 2? I don't remember, like, to make it faster, yeah, I think you have to increase the, yeah, you have to increase the value. And let's make it 10. It breathes slowly, yeah, that's what it does. And you know what's cool? It should work in the terminal as well. Works. That's pretty cool. So, all right. So what if I scale it like 3 times as much? Right. So it's going to be 3 times. It's a big pogue. It's too excited. It's too excited. Okay, so it's gonna be 15. Let's make it even more excited. Oh my gosh! Oh my gosh! Zoshin! All right. Oh, there's some limitations with the FPS in the terminal, but I mean it's fine, I guess. It's so cool. Because this. Why is it so funny? I like that. What if it's gonna be like 20? It works relatively fast, not gonna lie, right? I really like that. I think here is the problem. There is a very interesting problem with the current approach of rendering that I didn't foresee. Is that the correct use of a verb? That I didn't see when I studied all that. Right, so what if you want to copy the texture, but part of the texture has to go outside of the screen? So this is kind of a problem, right? So imagine that you have a canvas, all right, and you have a texture. Let's maybe use a different color for that. Right, and you want to copy texture like this. How would you do that? You would try to take a sub-canvas of like this that overlaps with the original thing. Right now, when you try to do that, you will actually get your canvas clamped. So instead of copying this thing and filling it like that and squashing and stretching according to this size, you would actually squash and stretch according to this side instead, because it got clamped. So the question is, how would you even do it like that? I'm not sure. So that means we have to reconsider the algorithm, right? So I think copying should not be done from canvas to canvas. It should be done from canvas to canvas plus the rectangle, right? So I thought that I can get rid of that rectangle, but apparently I just can't do that, right? So I still have to do that, but I can do that off screen, right? So it's like a minor problem that it's like not worth doing it on the stream. All right, so okay, guy. So, and I wish I could, yeah, that pesky rectangularization, it is what it is. I wish I could compile this example to WebAssembly, but compiling this example to WebAssembly means that I need to compile this thing to WebAssembly as well. Like running STB image on WebAssembly is pain in the ass, right? Because it does I/O, so that means you need to implement the POSIX layer and stuff like that. We can do a very interesting thing. We can maybe implement a tool that takes a PNG image and converts it into C code. And in fact, I already did that before in my Suwon application. So you can probably see that when I go on a break, I run this timer, right? And this timer uses like a custom bitmap font that I hand drawn myself, right? You can find the source code of this thing in the on GitHub, right? So I'm gonna copy paste it in here, and for anyone who's watching on YouTube, I'm gonna copy paste it in here. So it's a very simple timer, and it has a thing called PNG to C. What it literally does, it accepts a PNG image and spits out a C file that you can include without doing STB or anything like that. In fact, it already like uses STB. So let me actually try to do that. I'm gonna take this thing and squish. I'm gonna copy paste it somewhere here. All right. So if I try to compile this thing, CO, I might as well actually do that in the build, right? Clang O, PNG2C. PNG2C, we'll probably need to link with the math library. Do we need to do anything else? We'll probably have to say that use includes from the third party, because this is where we store all of the STB libraries. Let's try to build the entire thing and see how it goes. And no such file, well, I have to probably do C in here, that's for sure. Okay, so it built the PNG, right, PNG to C. If I try to run it, it says provide the PNG file. Okay, so let's try to provide the sodium POG PNG, and it actually spits it out to the standard output. Yeah, right, let's kill that thing. Yeah, I accidentally killed the whole Emacs, but you get the idea, right? So I forgot that it actually spits it out to the standard output. Let's do the following thing: PNG to C. Sodium POG PNG, save it sodium POG C. There we go. And if I open sodium POG C, there we go. So it's actually pretty cool. So it literally parses it and bakes it into executables. So yeah, and since it puts everything on a single line, it actually also kills Emacs. But yeah, so you can just use that so to bake things. I think we can try to do that. I think it's a pretty cool idea. Right. So, and in example squish, I can literally include sodium POG C. Right, I'm including sodium POG C. And I suppose I can just remove the init and like everything associated with the init. It's not needed anymore. And let's try to compile this entire thing. Let's see. All right, so it requires these kind of things. So now we don't have src pog.c. All right, so we have to use png width, PNG height. And what else do we have? So here is src, and in sodium POG it's just called PNG. Okay, so PNG width, PNG height, PNG width. Do we need to do anything else? And surprisingly, that is it. I'm pretty sure that is it. So bin squish SDL. Okay, so that's cool. So that means I don't have to include STB anymore. So since I baked everything into the executable, I don't need to use STB, which means I can now go and enable WASM platform. And let's try to compile that to WASM as well. Let me see. Okay, so it requires error no. We can remove error no as well. Anything else? Sign F. Okay, so for the sign F, I suppose we can just do float sign F float, right? Because we have that implemented in JavaScript anyway. Do we need to have anything else? Okay, that's it. Cool. And now if I go to index.html, right? So maybe index.js actually. So 3D WASM, and I'm gonna put squish in here. Do we have localhost 6969? Okay, so we don't have that. Let's quickly enable it one more time. HTTP server 6916. Well, yeah, there we go. And boom. Did it work? Did it work? Not a function. We don't have a init function for whatever reason. And this is because I never actually exported it. Yeah, so the only function that I exported is the render. I suppose I also need to render export init function, which I'm not really sure is needed if I'm going to do everything like at compile time, right? If I'm gonna bake things. I don't think init is needed anymore, but yeah, so I made it work in WebAssembly. Right, it also works in the browser just by baking everything, and that's pretty cool. So who needs Jai after all? Isn't that cool? Isn't that cool? I think it's pretty fucking cool. Anyway, so I'm sorry. So there's something wrong with me. Okay, and we can also check this term. And it's a little bit slower, like, this is probably because the terminal itself is slow, right? So it's really cool. It's really, really cool. And I need to probably somehow maybe bake that into the process, if you know what I mean, right? So I need to put sodium POG somewhere, right? I need to put it somewhere, but the question is where. And another thing is that I also want to be able to customize some of these things. Inclusion guard and array name are not custom. Yeah, this is what I was talking about. That would be actually kind of nice if you could just customize them, like all of these names, because what if I want to include several images and stuff like that? That would have been interesting, but yeah. All right. So I guess I don't know. I didn't really want to stream for too long, so I think I'm gonna call it a day. Right. I think I'm gonna call it a day. All right. Does anyone have any questions? Maybe. Does anyone have any questions before I go? So today was a rather productive stream, I think. I think today was a pretty cool stream, especially like this one. It's just like, yeah, ASCII sodium POG. What is this font? It's a Comic Sans. I'm using Comic Sans font. See. Can you make STB libraries compile faster by not including implementation, compiling it once and then linking? Yes, of course. In fact, I'm pretty sure I can do it like that. O STB image O. Maybe I can even do it like C. Third-party STB image H. And did it actually work? I don't think so. you also have to do stb image implementation, right? Because by default, this thing acts like a header, right? So that means it should be able to do it like that. stb, but I don't see shit in dismissed, right? Where is the third party? Oh, okay, so it compiled it as the header, so it did the precompiled header thingy. So what we probably have to do with a single command is also do -xc to tell it that treat it as a C file, right? And there you go, it created O file, but it actually is so small. Yeah, but there is a way to do that in a single file. So there is a typo in the implementation. Implementation. There we go. Oh, okay. So, and it contains 145, and I'm pretty sure you can do stuff like maybe even 3. Right, you can just precompile this thing. Yeah, I guess you can do that. Maybe I'm gonna do that off screen, sure. Holy, oh, 3. And this is GCC. What about Clang? Clang. Let's take a look at the Clang. 11 seconds. 11 seconds. But it doesn't really matter because I don't really care about the speed when it comes to STB libraries because they're a part of the infrastructure, right? They're not part of what the library is actually doing, so. Does anyone have any other questions before I go, chat? Look at that. Look at that sodium pogging. It's freaking pogging. How do you make the terminal dynamic like this? Like what? I'm actually not using anything special. It's a ANSI escape codes, if that's what you know, right? So essentially, I print one single frame. You can print a single frame quite easily on the terminal, right? So let me actually go to the examples, vc.c. And here's where I do that. So I have an infinite loop and I print a single frame. After I printed the frame, I sleep for a certain amount of time and I use a magical code, magical escape codes. So what's gonna happen if I remove that? Let's actually try to remove that. And I'm gonna just like recompile the entire thing. Right, build sh. And I'm gonna run this entire thing. So, as you can see now, it's not being dynamic or anything, it's literally printing the animation frame by frame, spamming it into the terminal. Like, it's literally spamming everything, so it's not dynamic or anything like that, it's actually wave. It's actually kind of interesting, so what if I make it bigger? I think it kind of looks cool, so squish. So let's do a factor of 10, I'm pretty sure it's gonna work. Oh yeah, look at that wave, pogging wave. So what these codes do, let's actually bring them back. Okay, so might as well actually clean everything and let's run it again. So as you can see, it's not spamming anymore and it's being interactive. So what this thing does, it controls the cursor. This thing says, okay, go the height amount of times up and go the width amount of times left. So essentially, at the end of the frame, it takes the cursor and brings it up back to its initial position where it was. And then I print the frame again and again and again. So the frame effectively overrides itself. And it's not something special. It's not a special terminal. It's a standard ANSI terminal. The standard ANSI terminals support that, and they support that through special escape codes that you just have to know. So you can actually Google them up, like terminal ANSI escape codes, and there's a lot of them. You can do all sorts of things. You can do colors, you can move the cursor around however you want, and it's just like it's built into your terminal. It's just built. Any program can just send those terminal codes and your terminal will do those things for you. How we choose the character for the image? Based on the brightness. So, I have a function color to character which accepts the color encoded in RGB32. What I do? I compute the brightness of that color. How I compute the brightness? I basically take all of the components and find the maximum of them. Right. Then, based on the brightness, I look up the character in the lookup table. So as you can see, the least amount of brightness is space. The most amount of brightness is the hash. Right. And depending on the brightness, I just choose between these characters. That's how I choose the character. I wonder if the WebAssembly version is GPU accelerated. Nothing in here is GPU accelerated, actually. So all of these animations are rendered pixel by pixel on CPU. Even if I do SDL, right? So if I do SDL, so there's a squish, SDL. This thing is also rendered pixel by pixel on CPU. Then it is copied to a texture that is then copied to the GPU, but it's just a means of displaying it. And in fact, I have a different example, like 3D, and it's also not GPU accelerated. This thing is not GPU accelerated. To be fair, it's a very simple thing, right? I should actually change the... I should probably put Olive.c in here instead of Bob. Why is it a Bob? Yeah, I should definitely put something else in here. It's kind of dumb. And speaking of, so where is my B? I think I need to bring this thing a little bit up. You know what I mean? Yeah, I think if I do it like that. I probably also have to enable 3D. Build SH. So scale. Okay, so it is not defined in 3D. Let's quickly do that. So where should we define it in 3D? I think it should be like around like maybe 10. Different examples should define that for themselves. Oh, okay, so B became a little bit better, I think. Maybe. But we'll also have to add another thing there. Oh yeah. Okay, so I guess that's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you on the next Resizing session. So yeah, love you.